Good morning, my dear student. So today we'll talk more about second order differential equation, or a system of two first order equations. You already knew that a given system of two first order differential equation can be represented by a single second order differential equation, and conversely a given second order differential equation can be represented by a system of two first order differential equation. Then we know how to find out the fixed point of a first order differential equation or a system of two first order differential equations. So then we want to find out the nature of the fixed point. Then we want to draw the direction field of the system. You already know how to use the software I told you last classes. So now let us go to the note. So here autonomous means the autonomous, here the variable for a second order differential equation, when it is converted into, or when it is represented by a system of two first order differential equation, there are two variables, x, y, or x1, x2. So those are dependent variable, and the independent variable is the time t is the independent variable. So if independent variable is not involved, then we know the system is autonomous system. So we'll concentrate to autonomous system, but generally let us talk about a general second order continuous system. That means here the independent variable t is involved here. Okay, so this is a system of two first order differential equation. x1 and x2 are dependent variable and t is independent variable. Okay, so such type of thing happens when a natural phenomena is modeled by a differential equation. Say for example prey predator model, there are more than one variable. So therefore second order differential equation or system of two first order differential equation is frequently used in mathematical modeling or in continuous dynamical system. So this we have already done this part, how to convert this into a single second order differential equation, all these things. Okay, and then let us come to the last time we have discussed this one. Let us come to the this note. So how to find out the fixed point? How to find out the fixed point? Here the fixed point is the solution of the, when you put dx by dt is equal to 0, dx1 by dt is equal to 0, and also dx2 by dt is equal to 0. So you will have two equations, v1 is equal to 0, v2 is equal to 0. From these two equations you solve for x1 and x2. Okay, in case of autonomous, t is not present there. So from these two equations you solve x1 and x2, then the solution is a fixed point of the given system of two first order equations. So that is how we find out the fixed point for such type of differential equation or for such type of dynamical systems. So that is not too difficult to find out. Now I'm giving you then some of the non-linear first order differential equation. This is non-linear, okay, because here x1 x2 product is involved, x1 square x2 square is involved. So this is non-linear system of two first order equations. So how to find out the I want you to calculate the fixed point of such system, and this one also, how to find out the fixed point of such system. Okay, so you can do that one. So now let us come to the trajectory. Now when you solve this equation, let us come to the trajectory of the autonomous system. T is not involved here. Here also T is not involved. Such system is called autonomous system. So you can solve this equation. You can solve these two equations. How to solve? You convert it into a second order differential equation. Then how how to solve that equation. So after solving, you will get x1, which is a function of t. x2 is also a function of t. Okay, so they are called a trajectory. So they are called the trajectory. Okay, then how to find out the and they are called the solution, and how to find out the if we divide equation number 2 by equation number 1, you will get this equation. Okay, you will get this equation. Okay, so then you think about the solution of this equation, solution of x2 in terms of x1, okay, or either solution of x1 in terms of x2. Then you have a plane, x1 x2 plane. That plane is called phase plane. The time variable is not involved here, so x2 variable, x1 variables, yeah, they are involved here, and dx2 by dx1. If you solve this equation, you will get x2 in terms of x1, or you will get x1 in terms of x2. Okay, so then you think about a curve. Okay, with proper initial value. You think about a curve. That curve is called the trajectory or motion of the given dynamical system or differential equation. All right, again here also you can talk about the direction field. Such differential equation looks simple but may not be possible to solve it. You have to use computer to solve that one, numerical solution. I have already told you how to find out the direction field, how the direction field helps to understand the motion of the system, the dynamical behavior of the system. Okay, so then likewise in the linear first order system we did earlier, here also you can talk about the direction field. So in the earlier case, the direction field was the single variable x and the time variable, and here for autonomous system we are talking about a direction field for the phase space. That is the variable x2 variable and x1 variable is here. So the plane is called phase plane. So here also dx2 by dx1 will be the slope, okay, at a given point. So at a given point of x1 and x2 in the phase plane or in the phase space, if you evaluate this quantity, right hand side quantity, that will give you the slope and tan theta of that one, and you can find out the theta. Then you can roughly understand the direction of the tangent vector of the curve x2 is equal to some function of x1. Okay, so at every point you can think, you can use computer to evaluate those direction field. The totality of this field, we call it direction field of the given system of differential equation. Okay, so let us see some example then how to find out the direction field. In examination I can give you few points and find out the direction field. No, it is not possible to find out direction field in examination, but for some selected point, so you can find out. I have already explained you how to find out the direction of the tangent vector at a given point. Okay, so let us see that some typical example. Let us see. Yeah, let us go back to the this is the direction field for the system. Here I am using x and y. dx by dt is equal to minus xy. So when you use this software, online free software, don't forget to use star for the product. Okay, so if you put just xy, then it doesn't work, so you have to put star for the product. Okay, so first equation is dx by dt is equal to minus xy, and the second differential equation is dy by dt is equal to y into 1 minus x minus 3. So for this system you can find out the fixed point. Okay, and then you can this is a direction field. First let us clear, yeah, this is the direction field. Okay, so if you put a different function on the right hand side, you will get different direction field. Now let us see a solution curve over here. See, this is the solution curve. Okay, so on this solution curve, yeah, this direction field is tangent to this curve. Okay, so this is the curve, this is x2, this is x2 variable, x2 variable or x2 axis, and this is x1 axis. Okay, so this is the curve. You may not be able to solve that differential equation explicitly, but using computer method you can roughly sketch the curve of the system or solution curve or motion. Okay, so now let us see another one. How about here? See, so this initial point here, this is the initial point here. They may be very close, but their motion is diverse. One is going this side, another one is going this side. Such system we call it sensitive, sensitivity dependent on initial condition. Let us see one very near to here. Yeah, this is, see, the nature behavior is very different. So if the initial point is taken from here, the solution curve motion, the dynamics behavior is like this. Okay, so if you take here, then it this side. So the initial point may be very near, but the long term behavior of the system, they are totally different. Okay, then let us see here about what about this one. You see, this is the solution curve starting from here. Okay, starting from here. So likewise, if you think about the initial point here, say, see, the initial point here is very near to the initial point here, but they are behaving very, they are behaving diversely. Okay, so how about here? See, so you'll get, how about here, this one like this, but the next to this one neighborhood here, how about this one? See, it is, the behavior is, long term behavior is like this. One is going this way, another one is going this way. All right, such system, the initial condition may be very near, but the long term behavior is very diverse. Such we call it, later on we'll talk about sensitivity. Okay, so and then let us see the solution curve here. See, so it looks like that something is here, it is converging. See, it is converging here, so this, there might be some fixed point. All right, so yeah, here also. All right, so this is, how to use the software to draw the direction field of a system of two first order equation. System of two first order equation. You can do lots of, yourself. Let me give you one example that you can draw yourself. Let me give you one example. Yeah, let us go here. So suppose dx by, yeah, so dx by dt is equal to, let us say x1 plus 2, x1 is x plus 2 y, and then dy by dt is equal to, dy by dt is equal minus 2x1 or minus 2, x1 is x, okay, plus 5y, and then minus 9. So try to draw the direction field of this system using the software, and then you can calculate say for example direction field at the point, say for example direction field, try to find out say 2 1. In examination you cannot draw it, okay, but you can find out the at a certain fix at certain points, like say 3 4, and then minus 1 6, like this, okay, and then say minus 1 1. So at this 4 point you find out the slope, so then you can roughly find out the tangent direction of the tangent vector at the curve, okay. So try to solve this equation. First find out the fixed point, if there is any fixed point. There may not be some time fixed point also, so find out the fixed point if possible. Then try to find out the direction of the tangent vector at this point in the xy plane, and xy plane will be the phase plane or phase space, okay. So you can do that one. Next let's go to the note. So this is how we find out the direction field of the given system, okay. Another example let me give you. Find the solution curves or trajectories, okay. Find the solution curves or trajectory of the given differential equation system of equation, this one and this one. So you find out the solution, okay. First find out the fixed point, okay, then find out the solution curve or trajectories, and then you can find out the direction field also using that software. Next, nature of the fixed point, nature of the fixed point. Let us see. We already knew that there are 3 type of fixed point: stable fixed point, unstable or repeller fixed point, and saddle fixed point, okay. So a fixed point, a fixed point, let us denote it by xf. Fixed point is called an attractor of some motion, some motion. If limit t tends to infinity, xt is equal to xf. The long term behavior of the the long term behavior when t tends to infinity, the long term behavior of the motion or solution curve converges toward the fixed point for some motion, okay. That we call it a attractor fixed point, okay, or stable fixed point for some motion. And another one is called repeller. A fixed point xf is called a repeller of some motion, okay. I will explain you why we use some motion here. If limit t tends to minus infinity, xt is equal to xf, okay. So that type of fixed point is called a repeller for some motion, okay. So there is another type of fixed point called center of that one, center fixed point. So before going to the center, let me explain why we call it here some motion. Some motion, why we use this sum. So let us go back to the pen window. First let me see, let us open this one, okay. So xy plane, let us talk about the plane. Phase plane is xy plane, phase plane for some motion. Suppose the 0 0 is the fixed point here. This is y plane, y axis, this is x axis, okay. So suppose 0 0, this is 0 0 is a fixed point. Then some motion means starting from here, some motion, some motion. This is curve passing through this point and passing through the fixed point may be like this, it may be converging, the motion may be converging toward the fixed point. Okay, so for this motion, particularly for this motion, for this solution curve or trajectory, it may be in such a way that it is converging long-term behavior as t tends to infinity, it is coming toward the fixed point. But for some other motion, say for example, for some other motion like this, so it may be going out from here, from the origin or from fixed point, it is going away. From this side, it may be coming to here. Okay, like this. And for some other motion like this here, or trajectory, what may happen is that it is going away from this direction also, it is moving away from this direction also. Okay, so for this motion along this solution curve or trajectory, the motion is a, the fixed point is an attractor. Okay, that is why we use, for some motion. All right, that is why we use for some motion. So there may be a fixed point where for every possible motion it is coming toward a fixed point. That is also, that is just, we call it attractor. Okay, attractor. And that is why specifically why we use here for some motion. Okay, for some motion. All right, for some motion, if this tends to this one, that we will call it repeller. Repeller means it is moving away from the fixed point, and this one is called attractor. For some motion, it is, as t tends to infinity, it is coming to the fixed point. That means the motion is converging toward the fixed point. Okay, so that we call it attractor. All right, so yeah, then let us see. And there is another type of fixed point. It is called a center. Consider the system of equation. This system of equation, let us see this system of equation. So when you convert into the single second order differential equation, you can find out the characteristic equation. The roots are imaginary, then there will be sine and cosine function will be involved. The solution is center, the fixed point will be center. So what is the fixed point? Fixed point is here, 0 0 is the fixed point. You can easily calculate what is the fixed point. 0 0 is a fixed point. The equation of the trajectory is given by how to find out the equation of trajectory is find out dx2 by dx1. That means dividing the second equation by the first equation, you'll get this one. After solving, you'll get this one. Okay, this is this is standard equation of ellipse. All right, so ellipse like this. So this is the fixed point. So why we call it center? When alpha is equal to beta, alpha beta are positive constant, then it is this alpha and beta are positive. This is another constant. Okay, so this is ellipse. So fixed point, it is neither coming toward the fixed point, but it is it is moving around the fixed point in a elliptic orbit. All right, or circular orbit like that. So here also, so you can think about concentric ellipse or concentric circle. Okay, such type of fixed point is called center, because fixed point is at the center and the motion about the fixed point is a circular motion or elliptic motion. It is neither moving away from the fixed point or coming toward the fixed point. Constantly it is revolving. Okay, so here also, if you start from here also, the small fixed point will be here, a small ellipse will be here also, like this smaller one. So there will be lots of concentric this one, this is we call it stable fixed points. Center is a stable fixed point. Okay, a repeller is not a stable fixed point. Attractor is a stable fixed point. Likewise, center is also stable fixed point, center. So you can let us talk about more about some that direction field, because that is very important. Some more example I will give you. Some more example. Here in this chapter there are lots of calculations are there. First let us see the system dx by dt is equal to, say, x square plus y square plus 2x, and the second equation is dy by dt, so this is equal to xy plus y. So how to find out the fixed point? First let us find out fixed point. So if you put dx by dt is equal to 0, so fixed points are solution when fixed points are solution, fixed points are solution, okay, solutions of the equation dx by dt is equal to 0. That is what? X square plus y square is plus twice x is equal to 0. Then x y plus y is equal to 0. So first look at the second equation. This equation is equal to 0 means what? From here you will get y 1 plus x is equal to 0. So from here what you get? Y is equal to 0 or x is equal to minus 1. Okay, when y is equal to 0, the second equation becomes 0. When y is equal to 0, what happened? So from the first equation, let us see, when y is equal to 0, what you get? X square plus twice x is equal to 0. All right, so from the second equation, first equation, what you get? When y is equal to 0, x square plus twice x is equal to 0. So this implies that x is equal to 1. X, see here, x is here, plus 2 is equal to 0. So from here, what do you get from here? So this implies that x is equal to 0 or x is equal to minus 2. So from first you get you take y is equal to 0, then x is equal to 0 from the second. So 0 0 is a fixed point. Okay, 0 0 is also a fixed point. So when you put x is equal to 0, y is equal to 0, you get these equations are satisfied. So next, when you take y is equal to 0, then you take x is equal to minus 2. What do you get then? Y is equal to 0 here, x is equal to minus 2. So this is going to be a fixed point again here. When y is equal to 0, then you take x is equal to minus 2. That is also a fixed point. So you have two fixed points when y is equal to 0. When x is equal to minus 1, what do you get? When x is equal to minus 1, and this is 0. So if you take x is equal to minus 1 here, then what happened? When you take x is equal to minus 1 here, so what you get? I don't have much space, let me write here. Then it is y square, when x is equal to minus 1, 1, and then the minus 1, then minus 2. This is equal to 0. All right, so then what happened? Y is equal to plus minus root 3. So when x is equal to minus 1, if you take x is equal to minus 1, this is already 0, and then y is equal to root 3. This is also a, this is going to be a fixed point. Again, when you take x is equal to -1, then minus root 3, this is going to be a fixed point again. Okay, so this is how we find out the fixed point of such system. Then let us draw the, let us draw the this one. Let us draw the direction field of such system. Let us, what is the first equation? The first equation is what? X square plus x2 square plus twice x. So yeah, x square, this is x square plus, so y square, x square plus y square plus 2x y square, y square, let me put cap here, y square plus 2x 2, then you put star here. For variable, for constant it's okay, 2x, right? Then here you put whatever here, xy plus then x, so you have to put here star y plus y. Yeah, let us see the direction field. So this one, yeah, this is the direction field. Okay, let us see the solution curve or motion of the system starting from this one. Yeah, your arrow here is starting from here, then it is the solution curve. All right, how about this one? Let us see. Yeah, this is a solution curve. Here it is a solution curve, small one. How about here? Let us see. So yeah, this is a solution curve. Okay, so then how about here? Yeah, like this. Yes, loud. How about here? So, and then how about here? Yes, like this solution curve. Let us see here. It is like this. Here it is like this. Okay, so this is the vector field. So in examination it is not possible to use this software, and it is impossible to draw the direction field, but as I told you, I will give you some selected point. At those points, 4 or 5 points, and then at those points you have to draw the direction of the tangent vector at that point. Okay, so this is how we study the second order differential equation. So next, we will talk about some interesting example. We'll talk about some important example, say for example prey-predator model or something like that. So it is all about differential equation, and then talk about the fixed point and long-term behavior, the motion we study. Okay, so this is all about today's lecture. Okay, you try to solve those example I gave you, and then you send to me, okay, through WhatsApp. All right, so I'll check it.